Today, in this session, we'll be doing Cambridge A-level mathematics. The topic is trigonometric proof questions. For that, we have to remember few formulas. Even if you don't remember, the formula sheet MF19 will be provided in the examination, but it's always better to remember the formulas. It helps you. So starting from question number 1. So yeah, let's do some math. Starting from question number 1, given the identity sine square theta plus cos square theta is equals to 1. This is given to us. Sine square theta plus cos square theta is equals to 1. And we have to prove sec square theta is equals to 1 plus tan square theta. So how we will get tan? By dividing the entire equation by cos square. So divide sine square theta by cos square theta plus cos square theta upon cos square theta equals to 1 upon cos square theta. So sin square theta upon cos square theta, which is going to be tan square theta plus 1, which is equals to 1 upon cos square theta, that is sec square theta. Hence we prove the identity. This is what we have to prove. Second one, it says prove cosec square theta equals to 1 plus cot square theta. How will we get cosec square theta if we have sin square theta plus cos square theta? By dividing sin square theta in both LHS and RHS. So simply sin square theta plus cos square theta is equals to 1. This is given to us. Divide by sin square theta. Sin square theta. Because cos square theta by sin square theta will give you cot square theta. Yeah, divided by sin square theta. So simply sin square theta by sin square theta will be 1 plus cos square theta upon sin square theta is cot square theta, and that is equal to 1 upon sin square theta, that is cosec square theta. So this is what we had to prove. Moving ahead to question number 2 now. Before that, just give me a second. You can check the solution from here. And now moving on to question number 2. Question number 2. It says by using the double angle formula for cosine, prove the identity cos 4 theta is equals to 8 cos 4 theta minus 8 cos square theta plus 1. So this is what we have to prove using double angle formula. So first of all, cos 4 theta can be written as cos 2 theta plus 2 theta. And now we have to use the double angle formula, so which is cos a plus b. So cos a plus b, the expansion of cos a plus b is cos a cos b minus sin a sin b. So this is the identity that you have to remember. If not, it will be given in the MF19 formula sheet, but as I said, it's always better to remember. You can solve it faster. So now let's substitute the value cos 2 theta plus cos 2 theta. It can be written as cos 2 theta multiplied by cos 2 theta minus sin 2 theta multiplied by sin 2 theta. Simply we can just expand this and I'll just solve it here. So cos 2 theta, first of all, what was the expansion of cos 2 theta? Cos 2 theta is 2 cos square theta minus 1. 2 cos square theta minus 1, and because it is multiplying by, let me write it. So yeah, 2 cos square theta minus 1 minus sin 2 theta is 2 sin theta cos theta. 2 sin theta cos theta again multiplied by 2 sin theta cos theta. So 2 cos square theta minus 1 can be written as 2 cos square theta minus 1 multiplied by 2 cos square theta minus 1 can be written as 2 cos square theta minus 1 the whole square, and this can be written as, see, 2 into 2 4, sin into sin square theta, cos into cos square theta. We also have to remember what we have to prove. So yeah, moving ahead, this is 2 cos square theta minus 1 the whole square. So here we will apply uh, the identity a minus b the whole square. So a square minus 2ab plus b square. A square is going to be 4 cos 4 theta minus 2ab. So 2 into 2 4 and cos square theta plus b square, that is 1 only. Yeah, minus, we have to prove as, we have to take everything to cos. So minus 4 sin square can be written as 1 minus cos square theta and then multiplied by cos square theta. So this can be written as 4 cos 4 theta minus 4 cos square theta plus 1, and then this can be written as minus 4, let it be outside, or we can just multiply. So minus, let keep minus outside, 4 cos square into 1, so 4 cos square theta and minus 4 cos 4 theta, and now just open the bracket. So you will get 4 cos 4 theta minus 4 cos square theta plus 1 minus 4 cos square theta plus 4 cos 4 theta. So now put all the like terms together. So 4 cos 4 theta plus 4 cos 4 theta can be written as 8 cos 4 theta, and minus 4 cos square theta minus 4 cos square theta can be written as 8 cos square theta and plus 1. I believe this is what we had to prove. Let's check. Yeah, this. So yeah, proved. Let's move on to the second part. This was first part. So just give me a second. I'll just keep it here. This is question 2, and yeah, this was the first part. Second part is, show by counter example that sine 4 theta is not equals to or equivalent to 8 sine 4 theta minus 8 sine square theta plus 1. So here we have to apply the double angle formula for sine. So let's check. I'm writing it here, second one. Okay, we can expand this. Now we know what we have to do. We have to apply double angle formula for sine. So sine 4 theta can be written as sine 2 theta plus 2 theta. So what is sine a plus b? Sine a plus b. Sine a plus b, the expansion of sine a plus b, the identity is sine a cos b plus cos a sine b. So we have to use this identity to expand sine 2 theta plus 2 theta, and we have to prove that it is not equivalent to this. So yeah, let's move on. So how can we prove it? So I'm writing sine a, so sine 2 theta multiplied by cos b, that is 2 theta plus cos 2 theta and sine 2 theta. We have to prove okay, we have to convert everything to sine first of all. So sine 2 theta can be written as simply 2 sine theta cos theta, 2 sine theta cos theta, and cos 2 theta can be written as 2 cos square theta minus 1. Same for this, plus sine 2 theta can be written as 2 sine theta cos theta, and cos 2 theta can be written as 2 cos square theta minus 1. Everything is exactly the same, so we can take common, or we should have taken common here only and multiplied by 2. So we can do that as well. From here we can take sine 2 theta and cos 2 theta common. So sine 2 theta and cos 2 theta common inside the bracket, 1 plus 1, so that is 2, multiplied by 2, you'll get 2 outside, and sine 2 theta cos 2 theta. So sine 2 theta as it is, and cos 2 theta can be written as 2 cos square theta minus 1. So let's move ahead from here. Moving on, 2 sine 2 theta. So 2 sine 2 theta can be written as 2 sine theta cos theta, and 2 cos square theta minus 1. So 2 cos square theta minus 1. So yeah, 2 sine theta cos theta, 2 cos square theta minus 1. So this can be written as, if I multiply cos inside, I can write 2 sine theta and 2 cos cube theta minus cos theta. Okay. Moving ahead, this can be written as 4 sine theta cos cube theta minus sine 2 theta, because this is 2 sine theta and cos theta, so this can be written as sine 2 theta, and this is not equivalent to what is asked to us. It is not equivalent to 8 sine 4 theta minus 8 sine square theta plus 1, like this. So hence proved. Just a second. So we are done with this. Let me keep it here. So this is the solution of the second part, and now we are moving ahead to question number 3. So what is question number 3? Question number 3 says that prove the identity 4 sine 4 theta upon sine square 2 theta is equals to tan square theta. So this is what we have to prove. Let me write it down. Question 3. Four sine 4 theta divided by sine square 2 theta. Sine square 2 theta, which should be, we have to prove it as tan square theta. Tan square theta. So okay, 4 sine 4 theta can be written as 4 sine square theta into sine square theta, and sine square 2 theta can be written as sine 2 theta multiplied by sine 2 theta. The expansion of the denominator will be, so the numerator will be as it is, sine square theta multiplied by sine square theta. The expansion of denominator will be, sine 2 theta is 2 sine theta cos theta, 2 sine theta cos theta, and sine 2 theta is again 2 sine theta cos theta. So we can simply check that 2 into 2 4, which will be cancelled with the numerator, sine theta with sine square, and now we have sine square theta by this cos into this cos, which is cos square theta. So sine square theta by cos square theta is tan square theta simply, and this is what we had to prove. So yeah, this is the solution for question number 3, and yeah, so I'll keep it here. Question number 3, this is the solution. Moving ahead with question number 4. Question number 4 says that show that sine theta in bracket cosec square theta minus 2 should be equals to cos 2 theta divided by sine. So let's check this one. Sine theta, question number 4. Let me write it here. Question 4. Sine theta and cosec. Sine theta cosec square theta minus 2, and this should be equivalent to cosec 2 theta, cos 2 theta, not cosec, cos 2 theta divided by sine theta, This is what we have to prove. How we will get cos 2 theta? So yeah, let's check. We have sine theta, so let's write sine theta as it is, cosec theta can be written as 1 upon cosec square theta can be written as 1 upon sine square theta minus 2. Moving ahead, if what will happen if I multiply sine inside the bracket? So it can be written as 1 upon sine theta minus 2 sine theta, 2 sine theta, that is divided by 1. So let's cross multiply. 1 into 1 is 1, minus sine theta will multiply, so minus 2 sine square theta divided by sine into 1, that is sine theta. So simply this is 1 minus 2 sine square theta is cos 2 theta divided by sine theta, and this is what we had to prove. So done with question number 4. Let me just keep this up for you. Yeah, so this is the solution of question number 4. Moving ahead to question number 5 now. This is question number 5, and they are asking us to show that sine 3 theta plus sine theta is equals to 4 sine theta minus 4 sine cube theta. So let me write this down over here. Question number 5. Sine 3 theta plus sine theta should be equivalent to 4 sine theta, 4 sine theta minus 4 sine cube theta, minus 4 sine cube theta, sine cube theta. So let's try to prove this one now. Let me use another color. So this is what we have to prove in this problem. What is sine 3 theta? Again, we have to use double angle formula for sine. What is sine 3 theta? So sine 3 theta can be written as sine 2 theta plus theta. And how can we write this as? This can be written as sine, we know that sine A cos B plus cos A sine B. So sine A cos B plus cos A and sine B. So we can use this in place of sine 3 theta, and we can write it as, so let's write it as sine 2 theta multiplied by cos theta plus cos 2, okay, yeah, plus cos 2 theta plus multiplied by sine theta, and this plus sine theta additionally, plus sine theta. Now let's expand this. We have to expand, but we have to convert everything in terms of sine. So we just have to remember that sine 2 theta can be written as 2 sine theta cos theta, 2 sine theta cos theta multiplied by cos theta again, plus again now we have cos 2 theta, and we have to convert everything to sine theta in terms of sine. So I can write it as 1 minus 2 sine square theta and multiplied by this sine theta outside the bracket plus sine theta. Now let's check. This can be written as 2 sine theta as it is, cos into cos square theta, which can be written as 1 minus sine square theta, plus now multiply sine it inside, so sine into 1 sine theta minus 2 sine cube theta plus sine theta. Here also sine will multiply inside, so 2 sine theta into 1, 2 sine theta minus 2 sine cube theta plus, I'm just adding this sine theta and this sine theta, or we'll add it at the end, sine theta minus 2 sine cube theta plus sine theta. Let's add all the like terms together. 2 sine theta, sine theta, sine theta, total 4 sine theta, and minus 2 sine cube theta minus 2 sine cube theta can be written as minus 4 sine cube theta, and this is what we had to prove. Let's check. 4 sine theta minus 4 sine cube theta. So while proving such questions based on trigonometry, we just have to check what we have to convert into ultimately. So right from the beginning till the end, try to convert it into that function. We have to convert it into sine. So this was question number 5. Let's move on to question number 6 now. Question number 6, it says prove the identity 4 cot x cos 2x upon sin 4x is equals to cos x square x. So let me write down this one. Question number 6. 4 cot x cos 2x divided by sin 4x, and which is equivalent to cosec square x. This is what we have to prove. So let's check. I'll use another color. Now 4 cot x and cos 2x, and we have sin 4x. Okay, can we write it as 4 cos 2x, and cot x can be written as sin upon cos. So I'm just writing cot x over here multiplied by sin x over cos x, and this, so multiplied by this cot x, I'm writing it as, no, not sin over cos, cos over sin, it's cot, so cos x over sin x and everything. And what we have in denominator, sin 4x, we have the expansion of sin 2x, right? Sin 2 theta, sin 2 theta is 2 sin theta cos theta. Similarly, now when we have sin 4 theta, it will be four sin 2 theta cos 2 theta. 4 sin 2 theta cos 2 theta. Let's write it down. So 4 sin 2 theta and cos 2 theta, and this is multiplied by cos x upon sin x. So we have to take x, not theta, so I'm just writing it as x, sin 2x cos 2x. So cos 2x will cancel out, 4 will cancel out, and okay, it will not be 4, just a second, I think we made a mistake. This will be, the expansion of sin 4 theta will be 2 sin 2 theta cos 2 theta. Let me write it down. So this is going to be 2 sin 2 theta cos 2 theta, cos 2 theta, cos 2 theta will cancel out, multiplied by cos by sin. So this is going to be 4 and then cos x upon 2 ones are 2, 2 twos are 4, so just write down 2, and then sin 2 theta is 2 sin theta cos theta, 2 sin x cos x, and we also have this sin x in denominator, so sin x. So 2 will cancel out, cos will cancel out, and now we have 1 upon sin square x, which can be written as cosec square x, and this is what we had to prove. So yeah, this is the answer. This is the solution to question number 6. Yeah. Moving ahead, question number 7. Question number 7, it says root 2 sin theta, this is the question, root 2 sin theta minus pi by 4 is equals to sin theta minus cos theta. This is what we have to show. So question number 7, it is root 2 sin theta minus pi by 4, which can be written as, we have to prove it as sin theta minus cos theta. Yeah. So in this case we have to apply the identity of sin double angle A minus B. Sin A minus B, which is going to be sin A cos B minus cos A sin B, because this is for negative. This is the identity. So let's keep root 2 outside, and inside I can write this sin theta minus pi by 4 can be written as sin theta and cos B, sin A cos B, so cos pi by 4 minus cos A, so cos theta, and sine pi by 4. So write it like this and then expand this. So root 2, we don't have the theta value, so sine theta will be written as it is, sine theta cos pi by 4. Cos pi by 4 is 1 upon root 2. So 1 upon multiplied by 1 upon root 2, sine theta multiplied by 1 upon root 2 minus cos theta, again theta value we don't have, so cos theta sine pi by 4 is again 1 upon root 2, so multiplied by 1 upon root 2. Now we have root 2 outside the bracket, so let's multiply root 2 inside the bracket. So if you will multiply root 2 inside the bracket, root 2 from both the terms will cancel out, and ultimately we will get sine theta minus cos theta, and this is what we had to do. Basically this root 2 and root 2 will cancel out, and we'll be left with sine theta minus cos theta. So this is the answer. Let me keep it here. So this is the solution to question number 7. And yeah, we solved all the questions. There were 7 questions and we proved everything one by one. I hope this helped you to solve problems based on trigonometric identities, proof questions, where we have to convert one function into the given function. Question 6 and question number 7. So yeah, that's all for today's session. If you have any doubts or if you have some more questions where you need help, you can surely put it in the comment section. Bye. Thank you for watching.